everyone. This is chapter 9.5, which is a discussion on linear equations. And it's not linear equations like, from algebra, y equals mx plus b, nothing like that. This is a linear differential equation. And linear differential equations are of the form dy dx plus a function of x times y is equal to another function of x. So these functions are, of course, called p of x and q of x. Okay, and real quickly, let's just take a look at an example of one. And the first example I want to see is y prime plus 1 over xy is equal to, I guess, 1. Yeah, that's fine. So, yes, this is a linear differential equation. Notice y prime is the same as dy dx, so that's fine. And this is 1 over x, it's our p of x, and 1 is our q of x. So you can identify which are these pieces. What I'm going to do, though, is I'm going to notice something. What I'm going to notice is that I'm going to multiply both sides by x, and it's not an obvious thing to notice, but I'll explain in a second how we can come to this realization. And when you distribute this, you get x y prime plus y is equal to x. And there's something that's even more difficult to notice, is that, well, first off, linear equations are not necessarily separable. Some of them are. In fact, all of the separable equations we've seen are linear to some extent if you think about it. But not all linear equations are separable. This is an example of one that's not a separable equation. But there's something we can do with this. And it's hard to notice, but just kind of hear me out. So x y prime times y, think of it like this. If you think of it as 1 times y, x times y prime plus 1 times y is actually a product rule. The derivative of x is 1, derivative of y is y prime. So actually, this is the derivative of the product x times y. Now that's a little hard to see, but we'll actually develop tools that'll help us find this more easily in a second. But think of using a product rule here. Derivative of the first is 1 times regular of the second is y, so that's 1y, plus the opposite way, regular of the first is x, derivative of y is y prime. You indeed get this left side. So now all we need to do is undo the prime by anti-deriving with respect to x. So the integral of xy all prime dx is equal to the integral of x dx. I forgot the equality symbol. There we go. Okay, just like that. And here the integral and the prime dx cancel out and you just get xy. Here we get the antiderivative of x, which is x squared over 2, plus c. And then finally we can divide both sides by x to get y by itself. So y is x over 2 plus c over x. And then of course you can solve for c using some initial condition or rewrite it in any different way you choose, and that's fine. But regardless, y is by itself and there's no derivatives anymore. So we've solved this differential equation. Now I want to generalize this phenomenon here. Notice this red x that I multiplied to both sides was something that you can find in general, and we're going to see that right now. Okay, so if you think about how we treated that x when we multiplied x to both sides, well, we multiplied x to both sides, and on the left, after distributing x, this became a product, and it was x times y all prime. So what we want to do is we want to find, you may or may not have seen this acronym before, want to find a function I of x such that when you multiply I of x to the left and distribute, after distribution what you end up with is I of x times y all prime. So you want this to be essentially an anti-product rule situation. So I'm going to expand this out a little bit and let's see what happens. So we get this. Nothing crazy. But notice something, that in order for this to be true, well, if you use a product rule here, you're going to get I of x times y prime. So that's the first guy, so that's okay. The first one has been checked out. And then plus derivative of I, which is I prime of x, and I ran out of space, but it's fine, times y. So this should be I prime of x times y. Now the y part is okay, because our y is right here. Right? See that? So now what we want to do is we want this to be satisfied. So basically we want I such that Well, I prime of x is equal to I of x times p of x. Keep running out of space. It's fine. So yeah, actually, is this a separable equation? I'm not sure if it is or not. We'll see right now. But regardless of if it is or if it's not, we're going to find I of x in the general case, and let's see. Alright, so it's a little tricky, but as it turns out, this is indeed a separable equation. If we treat y as our dependent variable, so this is going to be di dx, is equal to I times p of x. So I'm removing the of x part of I just so we can separate more easily. If we, separate, we get 1 over I di is equal to p of x dx. Perfect. Now antideriving both sides. The antiderivative of 1 over I is ln of I. And then this, we don't know what the antiderivative of p of x is, so I'll just leave it as integral of p of x dx. Notice I'm ignoring the absolute value scenario. In reality, we only need to find one particular I of x, so I'm not even going to write plus c after we antiderive. And you can try these things to kind of see why we don't need them, but the reason why is because the purpose of I of x is to multiply both sides by I of x. When you multiply both sides by I of x, the plus c part will just cancel out, and that's a little hard to see, but we'll see that right now. But the plus or minus part at least will cancel out because we're multiplying both sides by positive I or negative I, whatever the case may be. Just divide by negative. But yes, let's see the plus c part of that. So to get I by itself, we're going to take both sides as powers of e. So remember, e to this equals e to that. Okay, good. So on the left, they cancel, so we just get I is equal to this, e to the integral of p of x dx. And this is why we don't care about the plus c, because remember, when you have e to the something plus c, you can write it as e to the something times e to the c. E to the c is just another constant c, so you multiply it. So if you were to multiply everything by a constant times something, you can just divide by the constant. It's a little technical, so I guess long story short, you don't need it. But yes, this is indeed how you find I of x. So I of x is just e to the integral of whatever p of x is. Great. And now if you multiply both sides by I of x, you'll indeed get what we want, and let's see. Alright, so now let us recall I of x was this, e to the integral of p of x dx. And if we multiply both sides by I of x, let's see what happens. Now remember, this is just y prime. So, in fact, I'll just rewrite it as y prime. I like that better. Sounds better. So multiply both sides by I of x. On this side, we'll just get q of x times I of x. That's fine. On the left, I'll actually distribute the I of x into each of these. So it's going to be I of x, y prime, plus I of x times p of x times y. Okay, so now, listen. Since I of x is e to the integral of p of x, what does it mean about I of x times p of x? Well, we already said that we wanted it to be the case that I prime of x is equal to I of x times p of x. And it makes sense. Because the derivative of e to the something is itself multiplied by what? By derivative of the power. So what's the derivative of this power? Well, it's the derivative of this integral. And the derivative in integrals cancel, so p of x just gets dropped down because of chain rule. And notice, since this, e to this part is just I of x, we indeed get that I prime of x is equal to p of x times I of x. So this term here is just I prime of x. In other words, this whole left-hand side is I of x times y prime plus I prime of x times y, so it's really just I of x times y all prime. Great. Now, it's equal to what? It's equal to q of x times I of x. You can undo the prime by anti-deriving, and then you can get an explicit form, which is actually a formula for y, which is really nice. So let me just erase this real quick just to show you that. We can do this real quick. So integrate both sides with respect to x to get rid of this this prime. So technically it's dx, but that cancels out too, so it doesn't matter. Here we need dx though. So we'll get I of x times y is equal to the integral of q of x times I of x dx. And you can solve for y by dividing by I. Have I run out of space? Nope, I haven't. Let's write it here. So we'll get y is equal to 1 over I of x times the integral of q of x times I of x dx. Perfect. So this is actually kind of like the grand solution to any linear equation, any differential linear equation anyways. And let's do an example right now. You know what? Let's redo the example I showed you using this knowledge. Let's see what happens. Alright, so this is the example we saw before. Y prime plus 1 over x, y is equal to 1. Now, remember, if we label things accordingly, this is p of x and this is q of x. Perfect. So now all we need to do is find I of x. So that's the first step in the process of solving a linear equation. Well, the first step really is to make sure it's of this form. Then we can continue and find I of x. And I of x is always e to the integral of p of x. P of x is 1 over x dx. Remember I said you don't need plus e when you antiderive this. Antiderivative of 1 over x is ln of x. And again, you don't need the absolute values because we don't care about the plus or minus. E and ln cancel, so we just get x. This is exactly what I multiplied in red, if you remember that red x. Suspicious. It was suspicious at first, now not so much because we have the tools now. So this right here is super, super, super useful. So I'm going to even box it. By the way, the reason why it's called I of x, I should have name dropped this earlier, but this is called the integrating factor. It's essentially the expression you multiply both sides of, so you get an anti-product rule on the left, so that you compact it as all prime, and then you can antiderive. So let's see that here. Well, we kind of already saw it, so I guess we don't really need it, but let's just see it again. Multiply x to all sides of the equation, both sides of the equation. So distributing it into the left, we get x y prime plus 1 times y is equal to x. This can always be written as what? It can always be written as I of x times y. I of x is x. So we can always write this as I of x times y all prime. In this case, it's x times y all prime equals x. Antiderive to get rid of this prime part. Dx. I'm not going to write it. And then we get xy is equal to the integral of x dx, which is x squared over 2 plus a constant. And the rest is history. Just divide by x. And again, if there was an initial condition, we could have used that to solve for c, but we're not going to do that here. And we're going to see a little more complicated example right now. Okay, so now this example, it's not really that much more complicated like I said it would be, but it's a little more complicated, I guess. It's already of the form we like, and again, I don't like that dy dx for linear equations. I'm just going to write it as y prime, just so it's easier to kind of recognize what's happening. This is p of x, and this is q of x. Good. Notice we have an initial condition, so that'll be fun. We can find c finally. And what do we need? We need I of x, which is e to the integral of p of x. Okay. Now, antiderivative of 3x squared is, well, let's see. You just add 1 to the power and divide by that power. So it's 3x to the third divided by 3. So it's just x to the third. And again, it would be plus c, but for integrating factor, we don't care about the plus c part of it. So it's just e to the x cubed. So we'll leave it like that. Okay, great. So now we're going to multiply both sides by e to the x cubed. And yeah, let's just see what happens. So multiplying both sides by e to the x cubed, and remember, distributing it onto the left so that we don't waste a step. We get that times y prime plus, let me write it like this, 3x squared e to the x cubed times y is equal to 6x squared e to the x cubed. And let me just kind of erase this. Okay. That's fine. Now, again, what always happens on the left? What always happens? That's right. You can always write it as a product prime. Derivative of a product. Of what product? Of I of x times y. It's always I of x times y. What's I of x? It's this. E to the x cubed times y. If you don't believe me, you can go back and rewatch the steps because the evidence is there. Well, it's not really evidence, it's fact, I guess, at this point. But here we can see it in actually doing the product rule. Derivative of the first, which is itself times derivative of the power, which is 3x squared, see that? So 3x squared times e to the x cubed. Regular of the second, so that's the second term here. And then regular of this, which is that, times derivative of y, which is y prime. So it indeed gives us this. So this is true. But again, that'll always happen. When you multiply through, on the left, it's always I of x times y, all prime. I can't emphasize on that enough. Because that's where people struggle. Okay. Equals this. Now to get rid of the prime, we'll anti-derive. So we'll get e to the x cubed y is equal to the integral of 6x squared e to the x cubed dx. And just looking at it, I want to use u sub because I don't like that power of e. So if I'd only call this u, if u is x cubed, what is du? Derivative of x cubed is 3x squared, so it's 3x squared dx. And do we have 3x squared dx? Kind of. This is 6x squared dx. So if we break this 6 up as 3 times 2, pull the 2 outside of the integral, then we indeed have 3x squared dx. So these two combine to be our du. In other words, this integral is 2 times the integral of e to the u du using this substitution. So I've rewritten this integral in terms of u, and it's this, so we agree on that hopefully. And antiderivative of e to the u is itself, so that's going to be 2e to the u, and then we get a plus c. Perfect. And now e, of course, is x cubed, so this is really 2e to the x cubed plus c. And then on the left, we still get e to the x cubed y all the way down. And there it is. And all we need to do now is solve for y, and we can do that by dividing. But c is already here. So let's just solve for c right away using our initial condition. Shall we? Yes, let's. It's y of x. That's y of 0. So that means x is going to be what? X is going to be 0. Y is going to be y of 0, which is 1. So when x is 0, y is 1. So if we let x equal 0, we get the following. E to the 0 cubed is e to the 0 times y, which is 1, equals 2 times e to the 0 plus c. Now, of course, e to the 0 is 1, so you can just kind of think of it not being there. So we get 1 is equal to 2 plus c. Subtract 2, you'll get c is equal to negative 1. Great. Plugging that back in gives us e to the x cubed y equals 2e to the x cubed minus 1, because c is negative 1. Now finally, dividing everything by e to the x cubed, I'm going to do this a little strangely, but let's see if we can agree. So I'm going to get y is equal to 2 minus e to the negative x cubed. And that's our answer. Now let's see if we agree with me. When you divide both sides by e to the x cubed, on the left they cancel, you just get y. On the right, you have to divide it to each of these terms. Here, for the first term, you lose the e to the x cubed and it's just 2. Right? It makes sense they cancel. Here, this is going to be negative 1 over e to the x cubed. And notice 1 over e to the x cubed is the same as e to the negative x cubed. And that's exactly why I wrote it as a negative power. So I kind of skipped this step, but it's something I feel we deserve to see. So now I think I'm going to do a few homework problems. Okay, so here's a homework problem number 13. And there's no initial condition given, but there's a restriction given here. T is greater than 0. We'll have to see why that's the case in a little bit, why they give us that. It's not obvious yet, but we'll see that probably soon. Let's look at it. Is it a linear equation? Well, the highest derivative is 1. And in fact, remember, I don't like this. Let's call it y prime. It's better to call it y prime. Okay, good. And is it of the form we like? It's not of the form we like, because you want y prime to be not by itself, but you want no coefficient. So to do that, let's, to get rid of t squared, that is, let's divide everything by t squared. So divide through by t squared, let's see what we get. So dividing through by t squared, we get a bunch of cancellation. Here they cancel completely, just like we want. Here, only one of them cancels, so the power is 1 here for the bottom. And great, so now let's see what we get. After canceling, we get y prime is equal to, well, y prime plus 3 over ty, there we go, is equal to the square root of 1 plus t squared over t squared. Now looking at this frightens me. This is going to be very hard to antiderive. But luckily for us, we don't need to antiderive this because we haven't even considered the integrating factor yet. Remember that when you multiply both sides by the integrating factor, this may change because we're multiplying it by something. So let's see if we can find out what the integrating factor is. So let's label a few things. Remember that this is p of, well, I want to say p of x, but I guess the variable here is t. So it's p of t in this case, and this is q of t. Okay, good. So now what is the integrating factor? What's I of t? Well, it's e to the integral of p of t dt. The antiderivative of 3 over t is, well, 3 times ln of t. Okay. And now what? Well, we want to cancel the 3 and ln, but we can't quite do it right away. There are a few ways to do it. One way is to bring 3 in as a power, so it's ln of t to the third. E and ln cancel, so you get t to the third. Another way of doing it, that I think is maybe better for most people to see, is you can rewrite this as e to the ln of t all to the third. Because when you have a power to a power, you multiply the powers. Applying that property in reverse gives you this. Okay? Hope you can see that with the glare, sorry about that. But here they cancel out, the e and ln's cancel, and we get t cubed. So regardless of whichever way you do it, I of t is t cubed. So multiplying both sides by t cubed, let's see what we get. Remember the left, we have to distribute it, that's fine. Here, when you multiply this by t cubed, what happens? There's cancellation and we just get t. T outside of a radical involving t squared is just a u sub problem. Because the derivative of the inside is going to be 2t, and we have t to catch that on the outside. So we have nice cancellation. So kind of keep that in mind, but it's not going to be too bad. Well, what seemed to be frightening at first is not that bad at all. But anyways, distributing this on the left, we get t cubed y prime plus 3t, well 3 over t times t cubed. One of the t's cancel, so it's just 3t squared y equals, like I was saying, t outside of the radical of 1 plus t squared. Okay, good. Now what? Well, I guess now we can say what about the left-hand side. Remember, the left-hand side can always be written as, so like I was saying, if you got stuck here, it's okay because most people do. You kind of follow the process. Find the integrating factor, multiply both sides by the integrating factor. The whole point of doing that is so we can rewrite the left-hand side as a product, the derivative of a product. What product? The integrating factor times y. So it's going to be t cubed y. And again, this is easily checked. A product rule, just product rule. Leave this alone, times derivative of this is the first term. Then vice versa, derivative of t cubed is 3t squared times regular of y. You get exactly this. Good. So now we can, well, integrate both sides to cancel out this prime. dt. And now all we need to do is do u sub, like I kept emphasizing on earlier, to do this, and we'll solve for y by dividing by t cubed after the fact, and let's see that right now. Like I was saying, we're going to apply a u sub for the inside here. It's going to be u. So if u is 1 plus t squared, then what is du going to be? Well, du will just be 2t dt. And we don't have 2t dt, but we do have t dt. So if you solve for t dt by dividing by 2, then you get 1/2 du is equal to t dt. Perfect. We box this so it doesn't get in the way of our work. So now we will get on the right, the integral of t dt is replaced with 1/2 du. So I'll pull the 1/2 outside of the integral. Okay. All we're left with now is the square root of u, which is the same as u to the 1/2. Antiderivative of u to the 1/2, you add 1 to the power, divide by that power. So if you add 1 to the power, 1/2 plus 1 is 3/2. And then dividing by that new power, we will multiply by 2/3 on the outside. Okay? So, again, if you're think that's kind of fishy, all I'm doing is this. Applying the power rule for antiderivative. The antiderivative of u to the 1/2 is u to the 1/2 plus 1 over 1/2 plus 1. All I'm doing, though, is being a little more quick about it, writing 1/2 plus 1 as 3/2, and then instead of dividing by 3/2, I'm just multiplying the top by the reciprocal of the bottom. So I'm doing that a little more quickly. But in any event, that's what we get there. And the 2's cancel. So we get these cancellation of 2's. I'm, of course, missing plus c, so don't forget that. And now that we have 1/3 u to the 3/2 plus c, yes, we need to use our u sub again to substitute back in terms of our original variable, t. U was 1 plus t squared, so that's what we got. And on the left, we still have t cubed y. So all we have to do now is divide both sides by t cubed. And I think that'll be all. It just looks a little funny. It just looks really weird, but that's fine, I guess. So if you divide both sides by t cubed, you get the following. I guess we could write it as 1 fraction. Let's see. So maybe I could just... I'll just write it and let's see if we can follow. Sorry if I hesitated there a second. I just wasn't too sure if I should do this or not, but I'll just do it this way. Okay, so this is 1/3 times this. If I want to combine these two into 1 fraction, I will need to write this c as multiplying top and bottom by 3 because it's c over 1, if you like. So it's 3c over 3, right? So it's going to be, think of it like this. So it's going to be this 1 plus t squared to the 3/2 plus 3c all over 3, and then dividing by t cubed gives us the t cubed on the bottom because it's multiplied to the denominator 3. Now, 3c is just a constant, call it c. So let me write here that there's a reset, just so you can refer back to that in your notes. But there's a reset of the variable. 3c is replaced with just c. And that's how I want to leave this. I'm going to check to the back of the book because it looks a little fishy. There are possibly other ways of writing this answer, but I don't really want to get too much into it. I think I just want to leave it like this. So I'll see how they write it. They probably write it differently, to be honest, but I guess I'll just see in a second. And in any event, let's move on. I want to do a few more problems. Okay, so this is the next problem I wanted to do, number 17, but before moving on, I need to say a few things about the previous problem. First off, when they gave us t is bigger than 0, I believe the only reason of doing that was so that when the e and ln of t canceled, we would just get positive t because the absolute value of t would just be t. So we ended up getting something like this, to the ln of t cubed. Technically it would be ln of absolute value of t. I've always said to just ignore that, but this restriction kind of let us ignore that, because when they cancel you just get the absolute value of t. Cubed is, well, either negative t cubed or positive t cubed, depending if t is positive or negative. But since t is positive, then absolute value of t is just equal to t, so it's just t cubed. But again, we don't really care about those details. But the restriction at least allows us to know that the technicality is kind of avoided anyways. The other thing I wanted to say is that I checked in the back of the book, and they did not have it written like we wrote it as 1 fraction. They just multiplied both sides by t to the negative 3. So if you take a look in the back and see that, it's actually a little less work than what I did, actually. In any event, moving on to this one. They give us that, again, the same restriction. I'm assuming that's going to be because the E and ln's cancel and we just get t maybe. And they also give us this initial condition. But I kind of wanted to do this a little differently. So I am going to prep this by dividing by t first. I am also going to write this as u prime instead of du dt. So notice it's u in terms of t, so this is a t value, where this is our u value. Okay, keep that in mind. Also, this is not of the form we like. We first want to divide by, well, we want to divide by t, but first we want to bring the, I guess, y value to the other side. So just to remind us, we want this form. So if you want to write u's instead of y's and t's instead of x's, just to translate this better, this is what it should look like. So this 3u we need to bring to this side. So that we have t u prime plus 3u, I guess minus 3u because we're subtracting it to the left, is equal to t squared. So far so good. I know it looks funny because the letters aren't what we're used to, but if you make this translation and reason it out, you'll get this. It's just a little disorientating to look at because we're used to certain letters. Dividing everything by t gives us this. Right? T squared divided by t is just t. Let me erase this. Right? And yeah, like I said, I wanted to do something a little different. So this thing right here, this is p of t. You have to be careful. It's negative 3 over t. Okay? We're going to find I of t. So what's I of t? It's e to the integral of p of t dt. Antiderivative of negative 3 over t is negative 3 ln of t. And remember, if you bring in the negative 3 as a power, you get t to the negative 3, and the ln's cancel. I did it differently in the previous problem, but I'll do it like this in this one. So bringing the negative 3 in, we get e to the ln of t to the negative 3. The ln's cancel, and we just get t to the negative 3. It would be absolute value, but again, since we're given that t is greater than 0, we don't need the absolute values, and moreover, it's positive t. It's just t. So that's good. So that's I of t. Let me circle that. So I said I'm going to do this a little different, and here's how I'm going to do it. I'm not going to go through the motions of what we've been going through. We could actually just use the thing I boxed over here, like way earlier in the video. If you can rewind and you'll see what I mean. But it was the following. Maybe I can write it. Maybe I'll just write it over here. So we got this. We got y was equal to 1 over I of x times the integral of q of x times I of x. Okay? So it's 1 over the integrating factor times the integral of the right side times the integrating factor. So I'm just going to jump to that and let's see what happens. So remember, our y is u in this case, so we're going to get u is equal to 1 over the integrating factor, in this case it's t to the negative 3, times the integral of, well, q of t, which would be this guy here, that's our q of t, so t, times our integrating factor, t to the negative 3, dt. Now these of course combine by adding their power, so it's t to the negative 2, still inside of the integral. 1 over t to the negative 3 is just t to the positive 3, so that's fine. And we can antiderive by adding 1 to the power and dividing by that power. So this is going to be t to the third, let me write it as u equals t to the third, there we go, times what? May not have enough space, but it's going to be t to the negative 1, because when you add 1 to the power you get negative 1, divide by negative 1. T to the negative 1 divided by negative 1, so let me write it here, t to the negative 1 divided by negative 1 is equal to negative 1 over t. So it's negative 1 over t plus c. Okay, distributing the t cubed, we get u is equal to negative t squared, because t cubed over t is t squared, plus ct cubed. And we can find c. We probably could have found c even earlier on, but No, I mean, the way I'm doing it here, we'll find C right now. So this is our solution. We just need to find C using this initial condition. It's not going to be too bad. Let's see that right now. All right, so now here we go. We got u is equal to negative t squared plus c t cubed. And we're going to apply our initial condition. We're going to let t is equal to 2. When t is equal to 2, we're going to get u of 2, which is 4, equals negative 2 squared plus c times, well, I guess 2 cubed. Perfect. So that's 4 is equal to negative 4 plus c times 8. Add 4 to the other side. So we get 8 is equal to 8 times c. Divide by 8. What is c? It's just 1. Plugging it back into our solution. And I'll write this in a kind of better order, I think. We'll get u now as a function of t is equal to 1 times t cubed, I'll write first, minus t squared. Perfect. And we can check that this is a solution to the differential equation by plugging it into this. I'm not going to do that. You can try that. I'm going to go on to the next problem. I want to do number 19. It looks tough. Let's see how tough it is. Alright, so I don't know if we quite like the way I did the previous problem or not. Instead of going through the motions kind of like we're used to. Some people love it because it's a lot faster, but it's more to remember. You have to remember the formula basically. It's not that bad to remember because it kind of looks like the i's cancel, but one's inside the integral and one isn't, so they don't cancel. But yeah, I'm actually going to use it just because it's a little faster. But if you go through the motions of how we were doing it before, of actually multiplying both sides by the integrating factor and seeing that the left-hand side can be rewritten as a product, well, derivative of a product anyways, then you'll see that you'll get the same answer, in fact. So I'm going to do it like that, using the formula. But let's see. So first let's get this in the correct form. So I need to get a y to this side, to the left, by subtracting, I guess. Perfect. Now divide everything by x. So we'll get y prime. This over x is negative 1 over x times y. This divided by x loses an x in the power, and it's just x times sine of x. Great. So now we need to recognize what p of x and q of x are. Find our integrating factor. It's e to the integral of negative 1 over x dx. Antiderivative of negative 1 over x is negative ln of x. If you bring in the negative as negative 1 as a power, it's ln of negative x to the negative 1. Which I like doing it that way, but if you want to do it the other way, you can. Remember, it's just negative 1 times. So you write it as e to the ln of x, all to the negative 1. These cancel out, and you just get x to the negative 1. So that's our integrating factor. And we're going to apply the following formula. Y is equal to 1 over I of x times the integral of q of x times I of x dx. After applying the formula, then we'll get plus c after integrating, and then we will use our initial condition to find out what that c is, and let's get on to it. Alright, so I boxed a bit of information here that we just discovered. The integrating factor is x to the negative 1. Q of x, after moving everything over in the formula, ended up being x sine of x. And we want to use this formula, y is equal to 1 over I of x times the integral of q of x times I of x dx. So let's plug and chug, basically. So we're going to get y is equal to 1 over x to the negative 1 times the integral of q of x times I of x dx. And remember, sine of x, this is sine of x, not sine times x. So these don't cancel. But there is still some cancellation here. These two cancel. Technically this is, well, 1 over x, so since it's x over x, they cancel out. Also here, 1 over x to the negative 1 is just x to the positive 1. Okay, times the integral of what is left is sine of x dx. You have to be kind of careful. I skipped over this detail, but this is another spot where some people may make a mistake. Antiderivative of sine is negative cosine, and then we write plus c inside of parentheses before distributing the thing that was outside of parentheses. this is something that we kind of missed before when there's a constant. If it's a constant, it doesn't matter. Because when you distribute the constant, a constant times c is still a constant. But when it's not a constant like x, it really does matter. So you need those parentheses, okay? Distribute this. And that's y. So y is equal to negative x times cosine of x plus cx. Apply our initial condition, y of pi is equal to 0. Well, remember, that's x is pi, and that'll give us y is 0. So when x is equal to pi, what do we get? We get y of pi, which is 0, is equal to negative pi times cosine of pi plus c. Well, I guess c times pi. Alright, what's cosine of pi? Cosine of pi is negative 1. So this is 0 is equal to pi plus c pi. Subtract pi to the other side. Negative pi is equal to c pi. Divide by pi. They cancel. So we get c is equal to negative 1. Perfect. C is negative 1. Plug it back in. Y is equal to negative x cosine of x. Plus negative 1 times x, so minus x. And there we go. Great. So I hope you enjoyed this. I certainly enjoyed this. It's a very fun section. We did 3 homework problems, so I thought that was really cool. Let me know what you think, I guess, and I'll see you in the next video.